This is part 4 of section 6.5. Let's talk about orthogonal vectors. Two vectors v and w are orthogonal, and this is an extension of the idea of being perpendicular. Okay, perpendicular meaning a 90-degree angle. Two vectors are orthogonal if and only if the dot product of those two vectors are 0. And a 0 vector dotted with any vector equals the scalar 0. Any vector w, the 0 vector is orthogonal to every single possible vector. Okay? The problem I said we'd come back to here, we showed that dot product was 0, and we ended up with cosine of theta equals 0, which means that our theta had to be 90 degrees, which means they are orthogonal. So here, if we're asked to determine whether the two vectors are orthogonal or not, all we need to do is to find the dot product. So if I do v dot w, I get negative 20 plus negative 5 times negative 4 will be positive 20. Negative 20 plus 20 is 0, so these are orthogonal. Okay. Now let's find this one, decide whether it is orthogonal or not. V dot w, negative 3 times 4 will be negative 12, plus 4 times negative 3 is negative 12, which is negative 24, which is definitely not 0. So these two vectors are not orthogonal. Okay. So let's look at this one. We want to determine the scalar value c so that the vector v, which is 1, negative 2, and w, which is c, 4, are first orthogonal and b parallel. So part A, I would need the dot product to equal 0. So for part A, find v dot w. 1 times c is c, plus negative 2 times 4 is negative 8. And I want that to equal 0 because they have to equal 0 if they are orthogonal. And that means my c value must equal 8. Okay. Now, in order to be parallel, recall that what has to happen is v dot w needs to equal either plus or minus the magnitude of v times the magnitude of w. We already have an expression for v dot w, that would be c minus 8, is equal to plus or minus the magnitude of v. The magnitude of v is going to be the square root of 1 squared plus 2 squared, 1 plus 4 is 5. Times the magnitude of w is going to be c squared plus 4 squared, 16. Now I have a radical equation here, so I'm going to square both sides. This is a binomial squared, so make sure you multiply it out correctly. It's going to be c squared minus 16c plus 64 equal to, since these are two things are multiplied together, we square each piece. And it doesn't matter whether this is plus or minus. When I square it, it's going to become positive. So this will be 5 times c squared plus 16. Distribute. It's 5c squared plus 80. Now I have a quadratic that I need to solve. And so I'm going to move I'm actually going to move all of these over to here and flip my equation around. So 5c squared minus c squared is 4c squared. Add 16c to both sides. Subtract 64, and we get plus 16 is equal to 0. Now I can try to factor this, or you may recognize that everything here is divisible by 4. And why not make your numbers smaller and nicer if you can? This will give me c squared plus 4c plus 4 is equal to 0. This happens to be a perfect square trinomial, and it factors as c plus 2 squared equals to 0. And that means that our c value must equal -2. Okay, now the projection of a vector. One geometric interpretation of the dot product is obtained by considering the projection of a vector onto another vector. Okay, we're going to look at these images below for the vector projection of v onto w, which is denoted proj sub w of v. Okay, here we have our v vector and our w vector. Our resultant, which is the projection, is from here to here. And the way you find that is you imagine the vertical, a perpendicular line from the tip of v down onto w. And the projection is from your starting point to where that right angle equals. So if your double w vector is long enough, it just is this portion of it. Now, if your w vector is not long enough and your right angle would extend beyond that, then you just extend that with an imaginary line, and your resultant is still from your starting point all the way down to where that resultant is. If your angle is larger than 90 degrees, so that the right angle drop down will end up on the other side of w, you extend it in the negative direction, and your resultant is from here to here. Okay? The magnitude of v cosine of theta is called the scalar projection of v onto w. We're really not going to be doing a whole lot with this. The main thing we're going to be dealing with is vector projection, and this is the definition. If you're asked to find the projection of v onto w, you need the dot product of v and w, which is going to be a scalar number, over the magnitude of w squared, which is also a scalar, so this whole set of parentheses is a scalar, times the vector w. So we're going to have a scalar here, and we're going to multiply with the w. So let's find the projection of the vector v, 3, 5, onto the vector w, -4, 2. And this is going to equal v dot w over the magnitude of w squared times the vector w. Let's find v dot w. 3 times -4 is -12, plus 5 times 2 is 10, so that would be -2. Okay, the magnitude of w squared is just the magnitude, but leaving off the square root. So it will be -4 squared, which is 16, plus 2 squared, which is 4. So that is 20. And this set of parentheses, v dot w over the magnitude of w squared, is -2 over 20, which is -1/10. So what we have here is -1/10 times the vector w. And so this is negative 1/10 times negative 4, 2. And we simply multiply each of these two values by this scalar. So this will be positive 4 over 10, which reduces to 2/5. This will be negative 2 over 10, which is negative 1/5. So this projection, this answer, is the vector 2/5, negative 1/5.